Okay, Treg, here is the part 2 of this handout. We are now on to the back side. Let me go ahead and just say back side of this particular handout. So we are here. We're going to take a look at this first guy. Basically what we're doing is kind of looking at some of the points we looked at earlier, but we're going to be looking at them from a slightly different angle to make sure that we've got a better understanding of what's going on. It's always good to look at things from more than one angle when you're trying to understand the concept. So this is just kind of a rehash of what we looked at before, but hopefully this really infuses you with more of an understanding of the topic. So with that said, let's take a look at this one. We're going to be looking at the point where it is kind of the halfway point between the x-axis and the y-axis as you're traveling along here. And so, what is the terminal length from here to here? Well, the terminal length for the whole thing was pi over 2. So the terminal length right here is going to be half of that, which is pi over 4. So we got a nice terminal length right there for pi over 4. Alright. So let's go ahead and look at a few things. Note that it's halfway up. So if we drew a straight line from here to here, we would have what is known as the identity equation, the line y equals x. Okay? And let's refer back to the equation for the unit circle. We have x squared plus y squared. But what does y equal? Well, y equals x. So this becomes x squared plus x squared equals 1. And now we're just solving for x. Right, divide by 2. And now we take the square root of both sides, and we get x equals 1 divided by the square root of 2. And right now I'm getting the square root out of the denominator there because it is considered improper form to leave the square root in the bottom. So x equals square root of 2 over 2. Don't forget that positive or negative. Now we're looking for the coordinate that's in the first quadrant, so technically we're throwing out the negative, but note that the negative would apply for this point right here, and the positive applies for this point right there. Alright, so now that we have the x coordinate, we can plug that into the equation to find the y coordinate. This is exactly what we did at the beginning of the handout, but in order to get the practice, let's just go ahead and plug it in right now. So we have root 2 over 2, quantity squared, plus y squared equals 1, right? That coming from x squared plus y squared equals 1. And so we just work it through. So we have here 2 over 4 plus y squared equals 1. That 2/4 is the same as 1/2. Subtract 1/2 from both sides. Y squared equals 1/2. We take the square root of both sides, and you'll get the square root of 1 over 2, which is positive or negative root 2 over 2. And so again, the negative would apply for this point, and the positive applies for this point, right? Because everything in quadrant 1 is going to be positive, positive. Everything in quadrant 4 over here is going to be negative, negative. Alright, so that's it. We've got our points. We have here root 2 over 2, root 2 over 2. And that is the terminal point for the terminal length pi over 4. Okay, so now we're going to look at some other ones. Alright, so this one we're going to be looking at a terminal length of pi over 6. This is kind of roughly about in that spot. Alright, that's the one that, and the reason we're doing pi over 6 is because this is a terminal length that comes up kind of frequently. And so now we want to look, okay, well, if we're going to go all the way up to the top, right, that whole distance from here all the way to there, that's pi over 2. So we want to know, okay, well, what's the distance from here to here? Well, in order to find that out, we just take the whole distance, pi over 2, and subtract out the distance that we've already traveled, which is pi over 6. Okay, and we want to get these to be in a common denominator right there, so we multiply top and bottom by 3, and so we end up with 3 pi over 6 minus pi over 6, which turns into 2 pi over 6, which is the same as pi over 3. So this distance here is pi over 3. Okay. So now we went counterclockwise, pi over 6. We're going to go down pi over 6 now. It's about right here. Okay. So now we want to, okay, well, what is the come out this way and this way, what is that arc length right there? Going from there to there. Well, it's pi over 6 plus pi over 6. So 2 pi's over 6 gets us pi over 3. Note it's the same arc length. These two guys match. Alright? And I've got it kind of pulled out, but that pi over 3 refers to the arc length on the circle. And so since the circle has a constant radius, we can say that the distance between these 2 points is the same. So the distance from here is the same as the distance from here to here. Those are the same. Okay. So let's take a look at some of these individual points. Right, this point right here, we'll call that point. Call it point P. And it has coordinates x and y, right? Because those are the coordinates we're looking for. Because that's the terminal point we're looking for. And let's also look at, this distance right here. Well, from the x-axis up, that's y. And if you go down, that's also y. So that whole distance here, the distance from here to here, is 2y. The reason this is y down here is just because it's mirrored down. It's got coordinates x and negative y right there. Now what about this point right here? Well, that's got coordinates 0 and 1. Okay, so we got coordinates. We know that the two green lines are the same length. We know that that green line is going to have or has a distance of 2y. And since it's the two green lines are the same, this one also has the distance 2y. Okay, so these are some very important pieces of information. We're going to go ahead and apply the distance formula between this point and this point. And what we hope to get from this is some numbers that will tell us what the x and y coordinates are. So we're going to say, okay, what is the distance? Let's call this one. We'll call this the point y naught. And so we're going to try and calculate, or we will calculate, the distance between y naught and p. And so, again, the formula for the distance formula is change in x squared plus change in y squared. Alright, so we're going to be plugging in what we know. So the distance, well, what is the distance? Well, we already know the distance. It's 2y. Okay. And then for over here, we just plug in the points that we know. The two x coordinates are x and 0. And then the two y coordinates are y and 1. Okay, that's the formula. Alright, so let's go ahead and simplify this, work it out. I'm going to go and square both sides to get rid of that square root. So this becomes 4y squared on the left-hand side. And we got x squared here plus y squared minus 2y plus 1. Now, we want to get only one variable on here in order for this to work. So we want to, since we already have a bunch of y squared, let's take a look at this x squared term. We want to make a proper substitution. We want to get rid of that y term. I'm sorry, that x term. And so what we're going to do is look at the equation for the unit circle, x squared plus y squared equals 1. Well, note that this is the same thing as x squared equals 1 minus y squared. So we're going to substitute this amount in right there. So this becomes 4y squared equals 1 minus y squared. And you don't always have to put parentheses around it when you substitute in. I like to do that just because it makes it more obvious what I'm doing when I go back to see, review some of my work. Alright, so negative y squared plus y squared, well, those two are going to cancel out. And note that, well, first, let's go ahead and combine everything first. We have 1 and 1, so that's 2. And then minus 2y. So note that everything is divisible by 2. So why don't we make our lives a little simpler, divide through by 2 to get rid of some of these, to make the math just that much easier for us. So we've got 2y squared equals 1 minus y. So that's a little nicer to look at. We're going to go ahead and move everything to the left now. Okay, just like that. From here, you've got a choice. You can use the quadratic formula, since it's a quadratic equation to solve. You could also use factoring in this case. Quadratic formula, it's kind of a good cure-all for everything, so why don't we just use the quadratic formula. So here we've got that y equals, just kind of as a reminder, this is the quadratic formula. We should all be incredibly familiar with the quadratic formula. If you're not, please take a moment to review the quadratic formula. There's plenty of information out there on it. If you're still unclear, you can go ahead and send me an email. I do have some videos from other classes that I can supply you with. Okay. So now we just plug everything in. We have negative 1 plus or minus the square root of 1 squared, which is just 1, minus 4 times 2 times negative 1, all divided by 2 times a. Okay. Do a little simplification here, you get this. Subtracting, then adding, you get these two numbers, which simplifies to negative 1 and positive 1/2. There's a little mark right here on this line that should be a positive number. Make sure it's positive in your notes. So we got negative 1 and 1/2 are the two y coordinates. And so obviously y equals negative 1 would refer to this coordinate over here. We're not so much interested in that coordinate right now, so we're going to focus on the 1/2. So in order to figure out what the corresponding x coordinate is, you simply plug it in like we did at the top of the first handout. And so again we go x squared plus y squared equals 1. You plug in 1/2, so you get x squared plus 1/2 squared equals 1. And then when you work this out, you will find that x equals the square root of 3 over 2. Again, that would be positive or negative, but the negative would put us in a quadrant other than 1. And we're only really interested in quadrant 1 right now. So our coordinate that we're looking for was, or is, root 3 over 2, 1/2. Just like we got on the beginning of the handout. So again, that's and that would be our answer right there. Okay. All right, so now we're going to look at the last one. This last one is actually a little bit easier than that one, so we won't need quite as much space. But we're going to be looking for the terminal distance, not pi over 6. Now we're looking for the terminal distance pi over 3. So again, we start off here, and we go all the way up to there. Alright, so again, this is our point that we're looking for. Now, if this distance here is now pi over 3, in order to get all the way up to this point here, that's going to be another pi over 6. And then if we go another pi over 6 over, that'll be kind of symmetrical here. Look like that. So the whole thing, pi over 6 plus pi over 6. Again, is going to be pi over 3. Note this is looking very similar to what we did on the previous one. And so this distance right here, we can establish, because again this has coordinates negative x and positive y. Well, that means that that green is going to have a distance of 2 times x. And note that since that arc length is pi over 3, then we also know the distance from here over to here. Again, distance is 2x. We know the coordinates right there. The coordinates right there are 1 and 0. And so now, just like before, we apply the distance formula. So the distance between our, we'll go ahead and call out this coordinate x naught. And so this is the distance between x naught and p. Okay? X naught and p. And so again, we write out the distance formula. x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. And then we plug everything in. Now the distance is 2 times x. And we're going to go ahead and square both sides right off the bat to get rid of the square root. And now it's going to be x minus 1 quantity squared plus y squared. Or, if you want to preserve everything, y minus 0 squared. which ends up being y squared. Okay, so we got a nice equation to look at now. Let's go ahead and reduce this. We have 4x squared equals x squared minus 2x plus 1 plus y squared. Note that this is going to be exactly the same process that we did in the previous problem up here. And everything is symmetrical, so we're going to end up with a very similar looking answer. Now we're instead of replacing x squared, we will replace y squared. So we have, once again, x squared plus y squared equals 1. Solve that for x squared, y squared this time, and we get y squared equals 1 minus x squared. We're going to substitute that in. And you wind up with 4x squared equals x squared minus 2x plus 1 plus 1 minus x squared. Okay, so it should be obvious that we're going to get essentially the same answer as before, except with an x instead of a y. You can clearly see that the x squared is going to cancel with the negative x squared. We'll have a 1 plus 1 and then a 2x squared. Everything is essentially the same. So let's go ahead and cut to the chase. Now, whereas before we ended up with, it's going to end up being a quadratic, and we ended up with our y coordinate being these two values. Well, now that's what the x coordinate is going to be. So x equals negative 1 and 1/2, which was the y values of before. Alright, and now you plug these in to find your y coordinates, and we find that, and again, we're only taking the positive x coordinate because we're only interested in the first quadrant for right now. So we're just taking this guy right here. You plug that in, and you'll end up with a y coordinate equaling square root of 3 over 2. Again, same process that we did right there, which further leads to an x and y coordinate of 1/2 and square root of 3 over 2. Right? Just the variables or the coordinates are swapped from up above. Okay, and there we have it. And so let's go ahead and fill this in. This equals the point of 1/2 and root 3 over 2. It's worth noting that there are other ways we could have used the geometry to arrive at this conclusion, but since these two methods mirror each other, I figure that this is probably the best for this class to look at. So anyways, that is are some of the points that we've been looking at. These are very important coordinates that will be coming up time and time again. And so do not forget about them. Okay, so now we're going to talk about the reference number. Reference number is the shortest distance. I say distance, I should probably say not distance, but I should be saying arc length. And it's going to be to the x-axis. Alright, so it's once you've seen it a couple times, it kind of becomes a little self-evident. 7 pi over 4, notice that's just one. If we added just if there was one more pi over 4, we would make one full rotation. Okay, that is a terrible circle. Let's use technology to aid. There we go. Okay, that looks roughly center. Alright. So 7 pi over 4, that's going to be about right there. And so note that the shortest arc length to get to the x-axis here is going to be pi over 4. And so that's our answer. Our pi over 4 is our reference number. On this one, note that on our circle, well, that's right there. In this case, t bar equals t, which is pi over 4. So the reference number sometime is the terminal length, but clearly not always. 2 pi over 3, note that we're 1/3 of a pi short of being a half a rotation. Roughly right there. Right, so that's 2/3 of a pi, and so we just need 1 more of a third of a pi to get to the x-axis. So t bar equals pi over 3. Alright, so in this last one, note that we were just 1/6 of a pi short of 2 pi. Okay. And again, our reference line B, probably about right there. That's 11 pi over 6. And so what's left to get back to the x-axis? Well, that's just another pi over 6. So t bar equals pi over 6. Okay, that's it. That's the handout. If you have any questions, email me. I hope this really kind of helped you understand where these terminal points and lengths are coming from. And I will see you guys next time.